Hello everyone, welcome to Automation E2E. In this tutorial, I'll explain all the types of wait methods provided by Selenium WebDriver, a very important topic especially if you are preparing for interviews. Along with explaining the theory, we'll dive deep into real hands-on examples to show exactly how wait works in different scenarios. By the end of this video, you will have a crystal clear understanding of wait and feel confident using them in your project. Stick around till the end. This tutorial will clear up any confusion you have and give you a strong advantage. We'll kick things off by explaining synchronization issue, which is the reason why waiting strategies are essential in any web automation framework. Next, we'll dive into Selenium's different types of waits, providing a detailed look at implicit, explicit, and fluent wait and how each one behaves in various scenarios. Finally, we'll wrap up with best practices to make your wait strategies more effective. So, let's get started. Before diving into the types of wait, let's talk about why we need them and what problems they solve. If you have encountered a test fail because any element is loaded a bit too late, or a button wasn't ready to click right away, then you have likely encountered a synchronization issue. This happens because the script runs often faster than web elements can load on a page. Some elements load immediately, but others might appear only after a few seconds due to AJAX calls or background scripts. Without wait, WebDriver may try to interact with elements, click on a button, or read text before they are actually ready. When that happens, exceptions like no such element exception or element not interactable exception occur, causing tests to fail. That's why it's so important to recognize these scenarios and to handle them using wait strategies provided by Selenium. I'll walk you through practical examples of these synchronization issues so you can understand the problem more clearly. Let's start with the first scenario, where synchronization issue occurs because of AJAX and dynamic content. Here, elements load asynchronously after actions like button clicks or scrolling, which can cause failures if WebDriver tries to interact them before they are available. For this demo, I'll use UI Test Automation Playground site to show exactly how our test can be affected by synchronization issues in this case. So this is the site that we are going to use. So to test AJAX data, you have to click on this link, and then let me inspect this. And this button here will trigger an AJAX request. So as you can see, the data will appear after 15 seconds. So let's see how this happens behind the scenes. Let me inspect this one and see it will call this load label method, which will in turn call a API behind the scenes. Let's go to the network tab. Let's clear this out and see how this request is triggered. So I've clicked on this request. As you can see, you haven't yet received any response and it is in queue. So in this case, you can see the page is not loading. The page is already loaded. It's just we have to wait for this API call to be completed and receive the data on the page. So as you can see, the data is loaded here after a 15 seconds of delay. So in this kind of scenarios where the page is already loaded, but a background or dynamic data is to be loaded on the page, in that case, since the page is already been loaded, Selenium will try to interact with this element and eventually it won't find it on the DOM and it will throw no such element exception. I've already written a code here. So this navigates to the website, clicks on the AJAX button that we clicked, and then this clicks on the button that triggers the AJAX request. And finally, the data that is returned will be displayed in our console. So this is the code and we have not used any waiting strategy here. So let's see how synchronization issue affects this test. So let me run this program. Browser is launched. It has clicked on the AJAX data. As you can see, since the page is already loaded, Selenium has tried to interact with the element right away and you have already got an exception and the data is still not on the page. So in this case, we have to explicitly or implicitly wait for at least 15 seconds to allow this data to be on the page. So here you see we have got no such element exception. This is how synchronization issue occurs when we are dealing with any AJAX data or dynamic data. The next scenario in which we can encounter a synchronization issue is delayed element visibility or situations where we are dealing with hidden elements. In this case, elements are already present on the DOM but are hidden from the view, which causes issues when trying to perform actions like click that require the element to be visible. For this demo, I'll be using website internet.herokuapp.com to showcase this scenario. I'll mention all the sites I have used in this tutorial in a comment and pin it to the video. So for now, you guys focus on understanding the scenario and refer back to the sites later for your practice. This is the website and this is the dynamic loading page. In here, let's go to the page which has hidden element. The example one depicts that. So I'll go here, I'll right click, inspect. Here, when I click on start, a loader comes in. So we have to wait for a certain time so that this loader can pass and we can see this text. So let's inspect this text. Let's copy the XPath. You can see there is only one element present here. If I go back and come again and find the same element, you can see the hello world is already there. It's just not displayed. That is, display is equal to none, and basically it is hidden here. So if I try to interact with this element right now, it is still on the DOM, so you won't get no such element exception. Selenium will find it, but it will not be able to interact with that element since the element is hidden. So in that case, we'll get element not interactable exception. So if I click on start, still the element is present while the page is loading, but it is not displayed. That is, it is not yet interactable. Only when it is displayed on the DOM, it will be interactable. Let's write a code for performing this action. I'm back here. I've already written a code snippet here. I'll go to that website. I'll click on the first example. Then I click on start button. I'm not waiting here, if you can see, for the loading bar to complete, and I'm directly clicking on that element, and then I'll try to get the text. So let me run this program. So we are there. It has clicked on that element, and it has clicked on start as well, and you can see we have already got an exception, that is element is not interactable exception. So that is unexpected behavior that is happening. And even if I comment this out and if I try to get text, since the element is not displayed on the DOM, it will not throw any exception because I'm just getting the text. Since it is not displayed on the DOM, it will print a blank value here. Let me run this. So it is there, it's clicked on the first element, it's clicked on start, and you can see it has printed a blank value here. So that's why here adding wait is very necessary to interact with such elements which take time to load on the DOM. Let me quickly show you without using the Selenium wait. Let me use thread.sleep here so that you can see how wait can help here. I'll add a 7 seconds. Alright, so adding sleep is not at all recommended. One biggest drawback of this is, irrespective of whether the element is present on the DOM or not, it will still wait for 7 seconds. So just for your understanding purpose, I'll add a thread.sleep here and run the program. And later on, we'll compare all the waiting mechanisms that we can use in our automation framework. So there you go, it has launched the website. It is loading. The program is going to wait for 7 seconds now. Great. See, the element is here and it has printed the element. So in such cases, we need to add some wait here. Here are a few more situations where synchronization issues often come up. When elements appear with animation like sliding menus or pop-ups, they may not be ready for interaction right away, which can lead to element not interactable exception. For example, we have this Flipkart site. Here you can see this is a sliding menu, and if you try to access any element which is not yet displayed here, you can get element not interactable issue. Next is when you're interacting with dependent elements. Sometimes actions depend on a specific sequence. For example, a list of cities in a dropdown might only load after selecting a state. If the next action runs before the element loads, it will fail. Next is when dealing with progress bar. We have seen this in second example as well, where if we try to interact with element before loading spinner disappears, race condition can occur, causing test failures. Next scenario is redirection and navigation. For example, after form submission or button click, the page may redirect. If your script tries to interact with any element on the previous page, you will run into stale element reference. And finally, DOM updates. If the devs are using any JavaScript libraries like React or Angular, which often update the DOM, causing elements to reload, this can lead to stale element exception if the script does not wait for the update to complete. In each of these cases, Selenium's wait help manage synchronization. So whenever you are having trouble finding or interacting with an element, try using the wait statements that we are going to discuss now to avoid such issues. In addition to our scope, I would like to discuss page load timeout in Selenium. This method in Selenium is specifically used to set a maximum time limit for loading a web page. This is different from other wait strategies which control waiting for individual element rather than the entire page. So basically it defines how long the WebDriver should wait for a full web page to load before throwing an exception. This includes waiting for all elements, resources, and JavaScript on the page to load completely. This method is especially useful when dealing with slow loading pages. Let me show you how to declare and use it. Here I have already written a code wherein I am simply going to open google.com and print out that get method was executed. I have written here a code to slow down the internet. So basically this method would throttle my network and slow down the internet speed to the level of 2G. So in case we don't add the page timeout, by default it waits for approximately 3 minutes, which is a really long time. And in actual projects, we don't want our tests to wait for 3 minutes to timeout. So let me first run this and demo how much time it takes to load. I've started the timer here as well. So the internet is very slow because of the method that we added, and you can see it is waiting for more than 1 minute here. And here also you can see that it has not proceeded ahead of get method. So what I'll do is I'll just stop it. And now you can see once the page loading has been stopped, the get method was executed. So to avoid long waiting times of page timeout, you have to declare the page timeout here. To do that, you have to do driver.manage.timeouts.pageLoad timeouts, and here you have to pass duration of seconds. So let me add it as 20 seconds here. Now, once these 20 seconds are elapsed, Selenium will throw a timeout exception. So let me run this program. I'll start the stopwatch as well here. So you can see when the exception happens here. So it should wait for somewhere around 20 seconds. So as you can see, at almost 20 seconds, Selenium threw a timeout exception here. That is how we use page load timeout. Two key points to remember here are: page load timeout controls the overall page loading time, while waits handle the loading of asynchronous and dynamic elements on the page. Selenium will only start searching for elements once the page has fully loaded. So the waits we'll discuss now will apply only after the page is completely loaded. Selenium WebDriver provides different types of waits to manage the synchronization between the test script and the web element on the web page. As we saw, this is essential when dealing with dynamic web content, as it ensures that the script does not fail due to element loading at different times. There are three main types of wait provided by Selenium. First is implicit wait, explicit wait, fluent wait, which is an advanced form of explicit wait. So let's have a look at each of these in detail. Let's first have a look at implicit wait. An implicit wait in Selenium is a global wait, which means once declared, it is applied to all the methods that find the element in your script. It instructs driver to wait for a certain amount of time before throwing a no such element exception if it is not immediately available on the web page. Few key points to remember about implicit wait are: first, it is a global setting. That is, you don't need to define it for each element. Once set, implicit wait applies to all element finding methods throughout the WebDriver instance. If you want to set it again, it will override the previous value and it will take the new value. It has a polling behavior. That is, implicit wait polls the page every 500 millisecond to check if element has loaded. Let me show you using code how implicit wait behaves in different scenarios. Alright, let's revisit a scenario we looked at earlier in the video. We'll go to the UI testing playground site, click on the Ajax data, then click on the button to trigger the request. The data will take around 15 seconds to appear on the page. So as you can see, after 15 seconds, the data was there on the page. We had already written the code here. To make this clear, I'll print the start time and the end time of the find command to track the duration. So you can see exactly how much time this method takes to find that element in different scenarios. So let me add that. So we'll print the time at the start of execution of this command. Let's import the local time class. Similarly, in this statement, we're going to print the time when the execution of this command was completed. I'm going to surround the command with try and finally block, which will help me print the completion time even after getting exception. So I've written this code. This code will print the start time and the end time of the execution of this command. Let's have a look at first scenario wherein we are not going to add any wait here. So WebDriver will throw the exception immediately if it cannot find the element. This is the same thing we saw earlier in this video. So I'll just quickly run. We'll just see the time so that it's visible for you. Okay, here it goes. So it has clicked on the element. As you can see, it has thrown the exception right away. It hasn't waited for even a second here and the execution was completed. So to avoid this condition, we have to add wait here. Let's add an implicit wait here. So for that, we have to do driver.manage.timeouts, and in here we have to choose implicit wait. And here we have to pass how much maximum time we have to wait using the durations class. So durations has static methods, so we'll use seconds, and we will add it as, for now, let's say 10. So this is how we add implicit wait in our code. This implicit wait is a global setting, and once you apply it here, it will be applicable for all find element and find elements method of the WebDriver throughout the WebDriver instance. So implicit wait has a polling frequency of 500 milliseconds. That is, it checks for the element every 500 milliseconds until the timeout that we have set here reaches. Let's check a scenario where the element isn't found within the timeout. Example, we have taken here 10. So in this case, WebDriver will wait for the full duration and then throw the exception. As we saw, this site takes 15 seconds to load the data. In that case, 10 seconds won't be sufficient for the execution and the data will not be present on the UI. Selenium will eventually throw no such element exception again. So let's have a look at that and let's see how much time does it takes. So as you can see, it has not thrown the exception right away. It is waiting for the data to be loaded on the UI. So as you can see, it has waited for exactly 10 seconds here. And the web element was not on the UI, thus it threw no such element exception. In case when the element takes longer than the timeout, we will still get no such element exception, but in this case it will at least wait for some time before throwing that exception. Now let's see the third scenario. Let's see what happens when the element appears within the timeout period. For that, I'll set this time as 20, which is longer than 15 seconds needed for the data to load. This way, WebDriver should find the element in about 15 seconds and continue the execution without waiting for the full 20 seconds. This behavior sometimes confuses beginners and even experienced testers. Just remember that with implicit wait, WebDriver continues as soon as it finds the element. It will not wait for the entire 20 seconds here. Like in this case, the start and completion time will be something around 15 seconds, and it should not stop the execution for entire 20 seconds. So let me run this program. Okay, the browser is launched. Let's see the behavior. So the execution has started. It is waiting. So as soon as the data was loaded, Selenium has printed the data here and completed the execution. You can see the difference here. It is very close to 15 seconds, and the execution has not waited for the entire 20 seconds to consume. So that is how implicit wait behaves in the third behavior. It immediately returns the element once located and continues with the script without waiting for the full timeout. And that's how implicit wait works in different scenarios. The timeout you set should be optimal for your application. Usually 5 to 10 seconds is sufficient, but it depends on the specifics of the apps you are automating. Let's have a look at explicit wait now. Explicit wait in Selenium is more targeted and flexible waiting mechanism compared to implicit wait. Unlike implicit wait, which is a global setting and applies a blanket wait time for all elements, explicit wait targets individual elements and conditions. It instructs WebDriver to wait for a certain condition to be met before proceeding with the next action. If the condition isn't met, WebDriver will keep waiting up to maximum specified time before throwing an exception. It's used to handle situations where elements take varying amount of time to become available or interactable on a web. Here are some key points about explicit wait. It is condition based. That is, unlike implicit wait, which only waits for element to be present on the web page, explicit wait can check for various conditions like visibility, clickability, text presence, or even custom conditions. You can choose from several predefined conditions in the expected conditions class provided by Selenium. We'll see that in a while. Explicit wait is flexible and targeted and is applied only to a specific element or action. So it doesn't add any unnecessary wait to every command. It has a polling mechanism, and WebDriver polls the page at a default interval of 500 milliseconds. If the condition isn't met within the specified time, explicit wait throws a timeout exception. Let's write a code to check the behavior of explicit wait using different scenarios. For demoing different scenarios, we'll again use UI Test Automation Playground site, and on this site we have a section of auto wait. We'll go here. This page allows us to choose different types of elements and helps us play with its properties, like make it visible, enable, editable, etc. For example, let me disable this and apply it. As you can see, the button was disabled. We'll take an example of input field. As you can see, I'm able to write here. So if I disable this and apply this setting for 5 seconds, as you can see, it has been grayed out and I'm not able to interact with it. And after 5 seconds, it's been restored and now I can interact here. So we will write a code to select input here and then disable this element, apply it for let's say 5 seconds and try to interact with this element. Let's go to our code. I have already written a code here to go to the site, select an input box from the dropdown. So how to handle dropdowns in Selenium, I'll cover that in our next tutorial and provide the link in the I button of this video. For now, you just focus on the behavior of explicit wait. I'll briefly explain this code. So here we have created a new object of select class, provided the XPath of the dropdown, and we are going to select by value, and the value is input. So this value will help us select input from the dropdown. Then we'll uncheck the enabled option by clicking on that element. Then we'll click on wait for 5 seconds. And here, like we did at the time of implicit wait, we'll print out the start time and the end time of the execution. And here you can see I am finding the element and I'm going to send keys, which is Automation E2E, the name of our channel. So this is the code basically of the scenario that we discussed, and we're going to test it with our scenario where we are going to add implicit wait. So a question might arise that why we need explicit wait when we already have implicit wait. It can happen that an element is present on the web page but is not interactable. Implicit wait will fail to handle such cases and throw element not interactable exception, since it only waits for element to be present on DOM. So if we just add implicit wait for 10 seconds, despite we have added this 10 seconds, and this element, as we have disabled it for 5 seconds, we won't be able to interact with it until the 5 seconds are over. Implicit wait will only wait for the element to be present on the web page, and it won't wait for the element to be interactable. As in our case we saw, the element was already present on the web page, but after clicking on applying this property, which is disabling the element for 5 seconds, it won't be available for 5 seconds. So implicit wait will fail to understand that. Let's run the program and see the behavior. As you can see, it hasn't waited 5 seconds for the element to be interactable. Here, if you see that start and end time, it is 11 seconds. And this is the expected behavior of implicit wait, as implicit wait just waits for the element to be present on DOM, and the element was there when it tried to find it. Since the element was not interactable, Selenium has thrown element not interactable exception in this case. So that is why explicit wait is necessary. Let's see how we can add explicit wait here. Let us comment out this implicit wait here and see how we can add explicit wait here. So in our case, this is the element that is causing the problem, and we have to apply explicit wait on this element. So for that, first we have to declare explicit wait. To declare explicit wait, we have to create an object of WebDriver wait. So as you can see, this is a class. Let's name the variable as explicit wait is equal to new WebDriver wait. In here, as you can see, you have to pass first the driver, then the duration of timeout. So let's provide the driver here and the duration of seconds. Let again keep it as 10. Alright, so once you create an object of WebDriver wait class, you would have to apply it on this particular element. So to do that, WebDriver wait class has a method called until. So in this method, we have to pass what expected condition we want to fulfill. So to do that, Selenium has provided us expected conditions class. So this class has many static methods related to conditions. So let's select this and let's go to this class. It has many conditions. For example, title is, it waits for the title to be what string we have passed. Title contains whatever string we have passed. URL to be, URL contains. Similarly, presence of element located, visibility of element located, visibility of all the elements located by whatever XPath or whatever locator you have provided here. So similarly, there are many methods that are here, many conditions that you can play around with, but it is very important, guys, to decide which condition suffices your requirement. So you can have a look at all methods. I won't go in deep of what all the methods do, but these are mostly self-explanatory, like this one, like element to be clickable, like it waits for the element to be clickable. If you can also wait for the alert to be present on the web page, you can see if certain attribute has certain value. So there are many conditions here. Let's go back to our code and see. In our case, let's use element to be clickable. So we want to perform send keys action. So basically, if the element is clickable, we should be able to perform that action. So let me copy this and paste it here. All right, so this method here will return a web element. So let me copy this and paste it above and comment this line. Okay. So now our program will wait for the element to be clickable, and then only it will perform the send keys action here. So the second scenario that we will see would be when we have added explicit wait, and if the element is found and the condition is fulfilled before the timeout. So as we have just added a time for 5 seconds and the timeout is 10 seconds, WebDriver should be able to find that element within this timeout. In this case, WebDriver will immediately return the element once the mentioned condition is fulfilled and then continue with the script execution without waiting for the full timeout. So in our case, it should take somewhere around 5 seconds to complete the execution. Let's run this program. There we go. So it will wait for 5 seconds here. Great. As you saw, as soon as the element was enabled, WebDriver proceeded with the execution and sent the keys to the input box. Also, you can see here, the time that it took to execute the command was almost 5 seconds. Now, let us have a look at this third scenario, which is if the condition isn't satisfied within the given timeout. In this case, WebDriver will wait for the full duration and then throw timeout exception. So let us go back here, and since the element will be available in 5 seconds, let me make it as 4 seconds. In this case, so we have kept the duration as 4 here, but the element will be interactable only after 5 seconds. So basically this condition will not be fulfilled within the given timeout, and we should get an exception. Let's run this program and see how it behaves. So it has started the execution. And there you go, you have got an exception. So, as you can see, it has waited around 4 seconds here, which is the given timeout. And since the element was not interactable within the given time, it has thrown a timeout exception here. So, you can see the description that expected condition failed, waiting for element to be clickable by ID target. And it tried for 4 seconds with 500 milliseconds of interval, and yet it was not able to find it, hence it threw this exception. So this is how it behaves when we haven't provided enough timeout. Let's have a look at fourth scenario, which is when we provide incorrect condition. In this case, WebDriver immediately returns the element once located, and whatever incorrect condition we have provided is fulfilled. And since the correct condition was not fulfilled, we will get an element not interactable exception in this case. For example, in our case, we want the element to be clickable. Instead, if I would check the visibility of located element. In this case, even if you disable it, the element is visible on the DOM, and thus this particular condition would be fulfilled right away even when the element is not enabled. Thus, when it tried to send keys to that element, it will fail with element not interactable exception. So let's have a look at this behavior. So I'll just make this timeout to be 10 again. Let me run it and see how it behaves. So it failed right away. If you see, the execution start time and end time is not even more than a second, and you got element not interactable exception. Thus, it is very important to provide the right condition here. In case you fail to provide a right condition, there is no use of applying this explicit wait here. So this is how explicit wait behaves in different types of scenarios. Let's have a look at Fluent Wait now. Fluent Wait in Selenium is more customizable version of Explicit Wait. It allows you to define specific polling interval, timeouts, and even ignore specific exceptions while waiting for a condition. Fluent Wait gives you more control over how WebDriver waits for an element or condition, making it especially useful in scenarios where conditions may take varying amount of time to fulfill. Let me show you using code how to declare and use Fluent Wait. So to use Fluent Wait, first we have to declare it. For that, we'll create an instance of Wait interface, which is from Selenium support UI library. And here we are going to provide a WebDriver to it. Let's name it as Fluent Wait, and we'll create new Fluent Wait. Again, I'll provide here a WebDriver. And here I need to provide driver. So if we define, it will behave similar to explicit wait that we have seen earlier. But as we saw, Fluent Wait is more customizable. So the things that you can customize here is, first is something that even explicit wait has, which is with timeout. With timeout, here we have to pass the maximum timeout using durations class, and here we'll provide durations of seconds, and for this demo we'll keep the value as 10. So again, this timeout we were able to configure it in explicit wait as well. So the additional thing is polling frequency, and here we need to pass again the duration of seconds, and we have to give some value here. So this is the additional thing that Fluent Wait provides, wherein in explicit wait the by default waiting was 500 milliseconds. The by default waiting in Fluent Wait is also 500 milliseconds, but the additional thing is we can customize it to whatever value we have. Next is ignoring function, wherein Fluent Wait provides us the capability to provide exception that we want to ignore when Selenium is polling the web page. For now, I have written the generic class. So these are the two things that are customizable when it comes to Fluent Wait. Now let me show you with example how Fluent Wait will work. We will use the same scenario that we saw earlier, wherein we are going to disable the input box for 5 seconds. Here we have set the timeout as 10 seconds, and we have set the polling as 4 seconds. So Selenium will make the first attempt at 0th second. The second attempt would be made at 4th second. As the element will be enabled after 5 seconds, at 4th second, the element will not be enabled. Same in case of 0th case, it will be disabled. Now comes the third attempt. The third attempt would be made at the 8th second. And since it is after 5 seconds, the element will be enabled. The way polling works is, despite the element has been present on the DOM after 5 seconds, it will still wait for 8 seconds. So this use case is purely for your understanding purpose, and in real life, we don't keep this much time of polling. But for just showcasing you how polling works, let's take this example. So never keep such long polling intervals. To apply the wait on an element, let me copy this, and to apply wait on any web element, we have to use the same method that we used at the time of explicit wait, that is until. And in until, we have to provide a condition using expected conditions class. And from here, we have to check if it's clickable. So this method should take 8 seconds to get executed. So let's run the program and check the behavior. Browser is opened. So as you can see, the command was started executing and the element was restored, yet it hasn't pulled the DOM yet. And only after almost 8 seconds, it has sent the keys here, you can see, interacted with the element successfully, and the execution was completed. So that is how Fluent Wait works. You can make this polling customizable. So this is the only difference between explicit and implicit wait. All the other scenarios that we saw in case of explicit wait will work in the same way for Fluent Wait as well. So I'm not going to repeat those again. The only difference you have to remember is we can poll here and add an exception here. So it is a more customizable wait as compared to explicit wait. That's it about Fluent Wait. When implicit wait and explicit wait are used together in Selenium test, the behavior can be unpredictable and can lead to unexpected wait times, causing the test to behave inconsistently. If an implicit wait and an explicit wait both are set, the implicit wait can add extra delay to each polling attempt of the explicit wait. This can make the explicit wait less efficient, causing it to behave unpredictably and result in longer total wait time than expected. Also, when both waits are used together, WebDriver might first wait for the implicit wait timeout and then the explicit wait starts its polling interval. This can lead to redundant waiting period, especially if the implicit wait timeout is significant. Let's take an example of a behavior. Let's say an implicit wait is set to 10 seconds and explicit wait is set to 5 seconds to wait until an element is clickable. If the element does not appear immediately, WebDriver might wait for the implicit wait timeout before beginning to evaluate the explicit wait condition. This can lead to test waiting for longer than 5 seconds intended by the explicit wait. To demonstrate this behavior, I'm back to this UI automation playground site. You can use any site in this case. So to wait for the maximum timeout, let me inspect one element. Let's say this is X data. I'll copy the XPath. I'll paste the XPath. As you can see, it has found one element. So to reach the timeout, I'll just mess this XPath up and eventually we'll find 0 element. I'm doing this so that you can see what is the maximum time Selenium will wait for this element, which is never going to come on the web page. So I'll go back to the code and let me declare a explicit wait here. Explicit wait is equal to new WebDriver wait, and here I need to provide the driver and duration of seconds, and I'm going to set it to 5. So there you go. I've set this implicit wait to 5. Let me paste the XPath that I've copied, and we'll do explicit wait dot until an expected condition should be the element to be visible by dot XPath, and I'll paste this XPath. So my intention of setting explicit wait here is that I want to wait not more than 5 seconds. So if the execution goes ahead of 5 seconds, this element is never going to load on the DOM and I want the test to fail. So that is my intention. Let's say mistakenly, I have also declared an implicit wait here. So I'll do driver.manage.timeout.implicit wait, and the duration here is set to 10. So let's say I wanted some of the elements or the other elements, I wanted to wait for them for 10 seconds. And for this element, I didn't want it to wait for 10 seconds. I just wanted to wait for 5 seconds. So in either conditions, one main intention of setting this to 5 seconds was to wait for this element up to 5 seconds and not more than that. So let me run this program and see how much time Selenium will wait. So the element is page is loaded, but element is not there, and it has thrown an exception. So you can see that start time is 24 and the end time is 36. So it is almost more than 10 seconds. So this is the unexpected behavior that can happen. It is definitely more than 5 seconds. In addition to this 5 seconds, Selenium has added this implicit wait as well. So that is how this behavior can be unpredictable when you are using both implicit wait as well as explicit wait. So the best practice would be avoid using implicit wait and explicit wait together. Using both waits together can cause unnecessary delay and make your test script's behavior harder to predict. Here are some recommended approach. First is set implicit wait to 0 when you are using explicit wait. If you are using explicit wait in your test, it's best that you set implicit wait to 0 to avoid any overlap or conflict. This ensures that only the explicit wait is considered, keeping your test execution efficient and predictable. Second is use explicit wait only. Explicit wait offers more control and are preferable for handling specific conditions like waiting for element to be visible, clickable, or present. They are particularly useful for dynamic elements or conditions. Use implicit wait only for simple tests. If your test scripts doesn't need to handle dynamic element or specific conditions, that is, it's only checking static elements or performing basic checks, an implicit wait might be sufficient. So in summary, For complex applications dealing with dynamic elements and conditions, it is recommended to use explicit wait only and set the implicit wait to 0 when doing so. The reason is this avoids redundant wait time and provides better control over dynamic elements and specific conditions in dynamic applications. For simpler, non-dynamic applications, an implicit wait can be used alone to provide a uniform timeout. In the next tutorial, we'll dive into how to handle dropdowns using Selenium WebDriver. That's all from this tutorial. If you found it helpful, do like the video and subscribe to the channel. Thank you so much for watching.